Let us start with next example. Find the Cartesian form of the equation of the plane. R bar equal to, in one bracket, I cap plus j cap plus s into bracket I minus j plus 2k plus t into bracket I plus 2j plus k. Now this is equation of plane in vector form. Here unit vectors I, j, k are present and we have to write same equation of plane in Cartesian form. Before that, this is equation of plane in vector form, but this is also in parametric form. Outside second bracket s is present, outside third bracket t is present. So here s and t, they are the parameters. So this equation, it is in parametric form. So before converting it to the Cartesian form, we have to convert it into scalar product form. If position vector of one point in the plane is known and vectors parallel to plane are known, then we can write equation of plane in parametric form. Here A is point in the plane whose position vector A bar, B bar and C bar are the vectors which are parallel to the plane. Then equation of plane in parametric form, R bar equal to A bar plus lambda B bar plus mu C bar. Here instead of lambda and mu, parameters, scalar quantities are s and t. So position vector of one point on the plane A bar, I plus j. Vectors parallel to the plane, we shall denote B bar and C bar. So B bar, I minus j plus 2. C bar, I plus 2j plus k. Now this is equation of plane in parametric form, that we shall convert into non-parametric form or scalar product form. If A is point in the plane with position vector A bar and n bar is a vector which is normal to the plane, then equation of plane is R bar dot n bar equal to A bar dot n bar. This is equation of plane in non-parametric form or scalar product form. So first, equation of plane in parametric form we have to convert into scalar product form. After that we can get equation of same plane in Cartesian form. So here A bar is already known to us, but we want n bar, vector perpendicular normal to the plane. Here B bar and C bar, they are parallel to the plane, then their cross product B bar cross C bar, it is perpendicular to the plane. Find cross product of two vectors. Cross product of two vectors is a vector quantity and it is perpendicular to B bar and C bar both. But B bar and C bar, they are parallel to the given plane. Means B bar cross C bar, it is perpendicular to the plane. As B bar and C bar they are expressed in terms of unit vectors, we can find their cross product by using determinant. In first row of determinant, unit vectors I cap, j cap, k cap. In second row of determinant, we shall write coefficients of I, j, k for first vector B bar. So here 1, -1, 2. In third row of determinant, we shall write coefficients of I, j, k for second vector C bar. Coefficient of I not written means 1, 2, 1. Evaluate determinant I in bracket -1, -4, -5, -j. Second element of first row we have to take with opposite side. 1 -2, that is -1, plus k cap in bracket 2 -, +1, 3, -5 I cap plus j cap plus 3 k cap. B bar cross C bar, as it is perpendicular to the plane, means normal to the plane, we shall denote it by n bar. Now we know position vector of one point in the plane, vector normal to the plane, put those values here. So we get r bar dot in bracket -5r plus j plus 3k equal to, on right hand side, dot product of two vectors, a bar in bracket I plus j dot n bar in another bracket -5r plus j plus 3. Dot product of two vectors is a scalar quantity. As both the vectors are in terms of unit vectors I, j, k, find sum of product of I, j, k. 1 into -5, -5. Product of coefficients of j, 1 into 1, 1. Product of coefficients of k. In first vector, term of k is absent, coefficient of k 0, 0 into 3, 0. So equation of plane in vector form, r bar dot in bracket -5 I cap plus j cap plus 3 k cap equal to -4. Given equation of plane, it was also in vector form. This is also in vector form. But this equation, it is in parametric form. This is in non-parametric form. And we have to convert it into Cartesian form. So vector form can be converted to Cartesian form. Cartesian form can be converted into vector form. R bar, it is position vector of one point in space. Suppose coordinates of R, x, y, z. Then R bar, position vector of point R. Coordinates of R, they become coefficients of I, j, k. So write down vector R bar in bracket x I cap plus y j cap plus z k cap dot in another bracket minus 5 I cap plus j cap plus 3 k cap equal to minus 4. Again on LHS also dot product of two vectors, so it is a scalar quantity and both the vectors are in terms of ijk. Find sum of product of coefficients of ijk, x into minus 5 plus y into 1 plus z into 3. So we get minus 5x plus y plus 3z equal to minus 4. And this is equation of given plane in Cartesian form. So we can convert one form of equation into another. Next example. Find the vector equation of the plane passing through the points with position vectors I cap plus j cap minus 2 k cap, comma I cap plus 2 j cap plus k cap, comma 2 I cap minus j cap plus k cap. Now in this example, position vectors of 3 points in the plane are given and we have to write equation of plane in vector form. Suppose these are the position vectors of points A, B and C. Position vectors usually denoted by small letters. A bar I cap plus j cap minus 2k cap. B bar I cap plus 2j cap plus k cap. C bar 2 I cap minus j cap plus k cap. So we know position vectors of 3 points in the plane. If we know position vector of 1 point in the plane and vector perpendicular normal to the plane, then we can write equation of plane in vector form. So here position vectors of 3 points are known to us. So we can use position vector of any 1 point for this. But still we have to find vector which is normal to the plane, perpendicular to the plane. For that, we have to find vectors AB bar, AC bar. These are the vectors in space, and vector in space can be expressed as position vector of terminal point minus position vector of initial point. So from position vectors we can find AB bar and AC bar. It is a vector directed from point A towards point B. Here A is starting point, initial point, B is end point, terminal point. position vector of terminal point B, B bar, minus position vector of initial point A bar. I minus I cancel. 2j minus j. K minus minus plus 2k. 3. After that, AC bar, A initial point, C terminal point. C bar minus A bar, 2i minus I. So we get I minus j minus j minus 2j. K minus minus plus 2k. 3. Now we want vector normal to the plane perpendicular to the plane. AB bar and AC bar, two vectors in the plane. Their cross product is a vector which is perpendicular to the plane. So find cross product of two vectors. Dot product or scalar product of two vectors is a scalar quantity, but cross product or vector product of two vectors is a vector quantity. Both the vectors, they are in terms of ijk. So use determinant to find their cross product. In first row of determinant, unit vectors I, j, k. In second row, coefficients of I, j, k for first vector AB bar. Term of I absent here. Coefficient of I 0. Coefficient of j 1. Coefficient of k 3. In third row of determinant, write down coefficients of I, j, k for second vector AC bar. 1, minus 2, 3. Evaluate determinant. I cap in bracket 3 minus minus plus 6, so 9, minus j cap in bracket 0 minus 3 plus k cap in bracket 0 minus 1. So it is 9 I cap plus 3 j cap minus k cap. And AB bar cross AC bar perpendicular to plane of AB bar and AC bar both. So it is perpendicular to the required plane. Perpendicular, vector perpendicular to required plane means it is normal to the required plane. So we have denoted it by n bar. We know position vector of one point in the plane, vector normal to the plane. Now we shall write equation of plane in vector form. R bar dot n bar equal to A bar dot n bar. Put the corresponding values. R bar dot. Now n bar we shall write in bracket. 9i plus 3j minus k equal to, in one bracket, A bar I plus j minus 2k dot, in another bracket 9i plus 3j minus k. Find dot product of two vectors on right hand side. Sum of product of coefficients of ij. 1 into 9 plus 1 into 3 minus 2 into minus 1 plus R bar dot in bracket 9 I cap plus 3 j cap minus k cap equal to 14. So this is equation of plane which is in vector form. So here position vectors of 3 points are given and we have written equation of plane in vector form.
Welcome to Sanjeevani Education Group. Sanjeevani Education Group is a IIT NEET coaching hub which is renowned for producing the rankers in different competitive exams from national level 11th and 12th JEE NEET, Standard 10 NTSC MTSC, 6th and 9 Dr. Homi Bhabha Bal Vaidyanik exam, 5th and 8th scholarship exam, 7th Olympiads along with IIT NEET Foundation for all classes. We have experienced faculty who focus on the academic development of students. So dear parents, hurry up. For admission, visit Sanjeevani Education Group, plot number 13, Aditya Nagar, Gadkhera, Aurangabad, or call 95112 70135 or 95112 66680.